Everyone. Hello, can you all hear me well? Hello? Okay. I hope the sound is fixed right now. Can I get a thumbs up or something? How's the sound sounds like? Yep. Perfect. All right. That's perfect. Yeah. I believe that this was interference using the two different screens that we've been using. So right now, I guess it's all good. So I think we get started. So first of all, um, I will share my screen. So I hope you can all see it. So today we're going to work onto Arduino and electric circuits project. So this is basically how you can get started on your Arduino project. And before we get started, I wanted to go more also talking about our website, since we do have a lot of exciting positions that are opened up at the Developer Student Club. And therefore, I would like to invite you all into I would like to invite you all into applying to join the Developer Student Club. Our website is, as you can see, ucdavisdsc.com, and you can join in and learn more about our events, know more about us as a team, and be able to join our team itself. So without further ado, let's get started. First of all, I want to share with you this link today. And this is going to be kind of a project that would get you started into how you can build things with your Arduino. So to get started, I would like to share the link in the description. I hope you can all get to have the link open on the side as we're going through this. And so the main reason why I chose this is that we went through websites like Hackster.io and Instructables, and we talked more about how could we get our project to be working coming in from those websites. It is a really important skill to be able to tell exactly how you can mitigate that project that you see online and be able to get it on reality. So over here today, we're going to have two ways of creating such projects on your breadboard. Either using something like Tinkercad, And Tinkercad is like an online platform where you can connect your Arduino and other devices and peripherals together to help create your project. Or we would also be going through how to create it on an actual breadboard. And the importance of that is that we are going to be utilizing the kind of I would say virtual world of creating projects that we all love and learn. And for those people who actually receive their breadboards and Arduinos, they will be able to create it on their own breadboard. And so in order to get started with working on these projects, it's important to be able to read some of the key insights of what we're building and how can we do that ourselves. And most of these projects, either on Instructables or on Hackster.io, you would see that they give a small glimpse of how you can get started and what kind of circuitry should you expect. And this is important for students who are getting started into these kind of projects, especially those that are still skeptical on how they can approach such a problem by having something that they can already rely on in a kind of day-to-day kind of experience. So first of all, I want to start with you with Tinkercad to show you all how you can utilize that service and also at the same time be able to go through that on the design itself. Looks good? All right. So first of all, let's decide on creating a new design, right? So Tinkercad can be used in multiple ways. There are a lot of different shapes. There are a lot of different things that you can create on it. Its library is filled with amazing components that you could use in order to help create a lot of things at home. And so that's why I wanted to show that in a way that it's mainly online, so you can see the different components and shapes that you can be using, as well as the other things that we'll be using also today. So to get started, we would need an Arduino Uno, and that Arduino Uno on Tinkercad is also available with me here. If you can switch to the camera, this is my Arduino Uno. And so today, we're going to be using that in order to create our light sensor photoresistor circuit. And what this circuit basically does is that once you shine a stronger light on it, you would be able to tell exactly how much. So the photoresistors take in light and switches that into voltage. And what the Uno does is that it can read that voltage and read that measurement and be able to change the intensity of the LED light that we're going to have shine up. So our first step of the process is building the circuit. Building the circuit could be done on Tinkercad. There's also Tinkercad files. If you clicked on it, you can download them right away. And you can also, the best part about Tinkercad is that you can also kind of simulate it. So if we went over here and we started a simulation, you can see the kind of, you can see here the Uno is on. You can see the kind of resistor blocks and how we should expect it to be working. And you can also see the code if you're interested to. But this kind of coding is called block coding. But if you're interested in more kind of CES approach of it, you can still see the code over here on, for some reason, yeah, it is, yeah, this is a serial monitor. Anyways, so you could either go about it both ways. Over here, right now, we have our photodiode, we have our Arduino, and we have our breadboard. And so I think this is time that we connect our circuit together. So going in from what we see on the screen, we have that there are two leads of the photoresistor. One that goes straight to A0, which is a pin that we'll be able to code using Arduino IDE. And then we also have another pin that goes to positive terminal. right? And so in order to do that, we'll have to use jumper wires in order to make those connections. And jumper wires are available everywhere. It is just that you have to make sure to get the correct one, to make the correct kind of connections in order to make sure that the device is working as expected. And so over here, as we see here on the screen, I would love to use red for the positive terminal, right? And then we will be using, for us at least, brown for the connection between the other terminal of the photoresistor to A0 that we could see on the other side of this blank here. Let me use a shorter one. This is pretty long. Yeah. Let me use the black one to show it is going to A0. And you can see that A0 is always on the same part all the time at the Arduino, which is at the lower right corner. Okay, so that is our first connection. Our second connection is making sure that it doesn't go just straight to it. It goes also through a resistor. So let's make some space for the resistor, right? And it goes through a resistor, and that resistor goes through to ground. And so in these kind of circuits, you would want to know, okay, so what kind of resistor it is, right? Because we do have two different resistors with two different color schematics. Sometimes they would tell you that it's 200 ohms and 2.7K. You'll be like, okay, I could just use those right away. Or if you're not very familiar with that kind of, if they decided not to put in those values, then you would have to be familiar with the color code on the resistors themselves. And this is easy. You can just look up the resistor color code online on any website and be able to read it right away. I think this is something that we've been going through in our engineering courses, but I believe some of the CS students with us today would be a little confused about the resistor color coding. And so this is basically how we can read the resistors and being able to tell exactly how much it's going to be. So, and then to move forward with that, I think we need to put in our resistors over here. So this would be the resistor that goes into ground. Please note that we still haven't connected the ground itself. So this is something that we should do next. Yep. And okay, oh, this is not connected to ground. This is connected to ground right now. All right, and then we take a jumper from ground to the ground terminal on the Arduino itself. And then, so for that, I would highly recommend you use another light for that. We can go from here all the way to here. Usually people would also make a jumper from this ground to other grounds on this breadboard so they can utilize all different kinds of grounds. But whatever choice you might take, it all works. I would just want to say that the Arduino has a couple of grounds, so you can always utilize most of them. Yeah. And let me look if any of you had any questions. I'll have a look at that right now. Okay, sounds good. All right. And so right now, the next step of working through that is, since we already connected the photoresistor and have it all connected to each other, now it's time to connect the Arduino, the LED light. Please notice something, that over here, this leg is longer than this leg. And this is something that you're going to notice with any LED light that you'll be working with. So if you took any LED light, which I have right here, um, 1 second. Yeah. Say exactly. Yeah, it kind of fell from my hand, so I'm getting another one. Perfect. Okay. Um, yeah, those are hard when they fall in a pile of circuits. Here. All right. So moving on. So this is our This is our diode. This is our LED, right? LED is a photo emitting diode. So light emitting diode. Sorry. So we have like a lead, one leg that is longer than the other, and that leg is going to be on the right for copying exactly what the circuit's been saying. And then the longer leg usually goes to the port um, where we want to control it. And over here, you see that port is port 9. The reason that we're using the same ports that they are is that if we are still getting like exposed to this, we want first to be able to tell and test their code, and then we can start doing our own thing, right? And then our second resistor is a 4.7K, and I have that over here. So we'll just connect that. Okay. Yep. And then we connect it from here to ground, along with the other ground connections. All right. So those are the main circuit boards on the schematic itself. The last thing we have left is connecting the Arduino itself to the power. But before doing so, always make sure that you have all your other connections um, placed in correctly. And then we connect our Arduino. And we can do that right now. We'll launch in our Arduino IDE. Okay, for some reason, it is quitting. Okay, perfect. So this is your Arduino IDE. This is basically the place where you would want to set up your code that will be launched and uploaded to your Arduino. And so, of course, the input over here is going to be C programming language, and you can see that over there. If you're using Tinkercad, you can always code it using the blocks you can see over here. So if you want to code the schematic, you can always go over here and be able to code it. But for our own purposes, we're going to be using C, since I believe many of you are familiar with it. Of course, over here, you can always follow this kind of schematic, click code at the bottom to open the code editor, and then move on with these kind of instructions. So over here, when we have something like this, we would always want to initialize our variables. So our variables over here is sensor value, which is basically the value that we get off the sensor. On Instructables, they wrote it in this way, so you can always copy it up and be able to have it right away. So this is basically the setup. This is the setup portion of the code. When you want to create a variable and store it so that you can read it all the time from the potentiometer or from the photoresistor in our case, right? And so, in addition to also initializing the sensor value, which we still haven't had it in exactly. And then in the loop, right? In the loop, it's something that you want your code to run on repeatedly. And that is something that you want most of the time to be running while you're running your code. All right. So for instance, over here, we want to read the values from the sensor, right? And then we read that value from A0, which we connected them over here, right? And then being able to print in that on our serial over here so we can know what is the range of the printing, right? You can see that in this, these are just comments in order to help guide us through this. I believe once you're more familiar with it, you'll be able to tell right away. What usually we do is that after knowing the sensor readings, we usually map that sensor reading to a range of LEDs. So we're writing to the analog. So our analog over here would be our LED, right? To LED, which is connected to pin 9 over here for analog read. And then that is mapping the sensor value that goes in from 0 to 255. So those are the different levels that we have of the kind of current that we'll be dealing with. So what happens is that it reads from here, analog reads from A0, be able to tell what value it is, map, so this values ranges from 0 to 1023, and then we want to decrease the value from 0 to 255, and then being able, once we read something, we'll be able to output that into an LED, right? Makes sense? So I'll give you all 2 minutes in order to help create your own version of this, and I'll be back in exactly 2 minutes. If there's any questions, I'll be happy to help. I'm just waiting for everyone to get into my point, and we can move on from there. Hello? Yeah, okay. I guess there's a problem with the mic. Okay, going back to where we were. So since right now we have everything ready, it is time to verify uh, what we've been working with. So sometimes you have to change your port, make sure that it is connected to the board that you're using. I'm using an Arduino Uno. That is not verifying. Huh. Okay. This is interesting. Bad CPU type. Okay. So let me disconnect it and connect it again. Sometimes such problems might arise. It is an Arduino. Let's go with USB. No. Okay. Let's try. Let's try with one of the examples of a blink circuit. There seems to be something wrong that happened. It is on. It is loading. Okay. Yep. The board information is Arduino Uno. What is going on? Okay. So if you're dealing with these kind of issues, I believe the most important thing is to be able to tell exactly what is going on. So if you're using the latest version of Arduino, I guess mine needs an update. I haven't been using Arduino so lately, and so if that's the issue, then you might also check it out on Tinkercad, right? So over here, you also get to see how you can create that also on Tinkercad using such sample circuits. You can follow this over there, and you can get a free wired version of it too, if that's what you're interested in. So you can simulate it. Sure. And you can use it. See, as we're increasing the light intensity, it is switching on. As we're decreasing it, it fades away, and then goes back to dark. This is basically how our schematic should look like. Ours, if we had our code uploaded, would be the same thing exactly, because we did have the same connections, we have the same code, so you should expect it to work the same way as they did. And so if you have any other questions, you can always email us at dscucd@gmail.com, or you can also reach out to us on our website or any other station. Thank you all for coming in today. I hope you have a great day. If you'd like to see more suggestions, please let us know, and we'll make sure to be ready for that. Thank you.